Okay, we're going to be looking at something now called differential equations. Okay, now differential equations is the last thing that we'll look at from the unit 2 integration stuff. Okay, so a differential equation basically means that we're given an equation which is a function that's been differentiated. So for example, let's say that we had a question like this: the graph of a function passes through the point 2, 1, and the gradients of the tangents to the graph are given by dy by dx equals 2 minus 5x. The question then says calculate the equation of the function. Okay, so when it says find the equation, we basically need to find out what y is equal to. And remember that if you differentiate y, you get dy by dx, so it then follows that if you integrate dy by dx, you get y. Okay, so let's just take the first step of this one. So we're going to integrate dy by dx with respect to x, and that's going to give me y. Okay, now that makes sense because if you think about it, if you differentiate y, you get dy by dx, so if you integrate dy by dx, it brings you back to y. Okay, so that means that I'm integrating 2 minus 5x with respect to x. Okay, so remember, if you integrate a constant, you get the constant x, so 2 becomes 2x, and minus 5x becomes, well, remember that's a 1 up there, so that's minus 5x squared over 2. It's an indefinite integral, no limits up here, so I need to put on the constant of integration. Okay, so that's the function, but ideally I can now find a value for this constant of integration, and that's where this point here comes into play. So I know that the x coordinate is 2 when the y coordinate is 1. I know that the x coordinate is 2 when the y coordinate is 1. And that should allow me to find that constant integration. So 1 equals 4 minus 2 squared is 4, times it by 5 is 20, 20 divided by 2 is 10, so 2 squared is 4, times it by 5 is 20, 20 divided by 2 is 10. Okay, so I've got 1 equals minus 6 plus c, and then c will be equal to 1 plus 6, and c is equal to 7. So then y is equal to 2x minus 5x squared over 2 plus the constant of integration, which is 7. Final answer. So the basic pattern in these questions then is you integrate the differential equation to get an equation for y. If it was to integrate f dashed x, you would end up with f of x, for example, if it was functional notation. You then put on your constant integration. You then use the clue in the question, which is the point, which means you sub in x and y. When you do that, that should allow you to find the constant integration, which was the start of that process here. Once you get the constant integration, write out the equation for y again, but put on the constant integration at the end, and that's the final answer. Let's try an example 2. Okay, example 2. We're going to solve the differential equation dy by dx is equal to 3 minus 2x plus 6x squared when y equals 5 and x equals 1. Okay, so again, we need to find y, so that means we're going to integrate rather dy by dx. Okay, so that's the integral of the function 3 minus 2x plus 6x squared. Okay, integrate the constant, you get constant x, so 3 becomes 3x, then it's minus 2x squared over 2 plus 6x cubed over 3 plus the constant integration. I'm going to now simplify this, so that'll give me y equals 3x minus x squared plus 2x cubed plus c. I can now make my substitution. When x equals 1, y equals 5. When x equals 1, y is equal to 5. Okay, so that will then bring me 5 equals 3 minus 1 plus 2 plus c. 5 equals 4 plus c. C is equal to 5, take away 4, which is 1. Okay, so the function then is 3x minus x squared plus 2x cubed plus the constant integration, which is 1. Okay, let's try an example 3. Okay, so example 3, we've got f dashed x equals the cube root of x. So find f of x where f of x passes through 1, 3. Okay, so the original function f of x is given by the integral of f dashed x with respect to x. So that is then the integral of the cube root of x. So let's get rid of that root sign. That's going to be x to the 1/3. Okay, integrate that then, and that will give me we'll add 1 to the power, divide by new power, so 1/3 plus 1, that's 1/3, plus 3/3, that's 4/3, divided by 4/3, plus the constant of integration. Okay, so it's f of x equals, bring that up, flip it over, 3/4 of x to the 4/3 plus c. Let's reintroduce the root sign. 3/4 of the cube root of x brought to the power 4 plus c. Okay, let's make a substitution. So I was told this is all happening when the curve passes through 1, 3. So when x equals 1, y is equal to 3. And that's where x is equal to 1, and f of x is my expression for y, so it's going to be 3 equals 3/4 of the cube root of 1 brought to the power 4 plus c. That's 3 equals 3/4 of 1 plus c. 3 equals 3/4 plus c. Okay, c is equal to 3 minus 3/4. So that's then 12/4 minus 3/4, and that's 9/4. Okay, so I can now write the function out. So it's f of x is equal to 3/4 of x to the power 4 over 3 plus my constant of integration, which is 9/4. Final answer.